Let's pull back the curtain on the hidden world that makes all of our favorite apps and our entire digital life actually work. We're talking about software testing. It's the unsung hero behind every piece of software you use. Oh, you know the feeling. You're just about to pay for something, post that perfect photo, or send a super important message, and boom, the app just gives up. It freezes, or maybe it just vanishes. That moment of pure frustration, that's a software bug in the wild, and it's exactly why we need to talk about testing. Okay, so let's get one thing straight right from the start. This is a fundamental law of the software universe. Building a piece of software that is 100% completely, totally flawless, it's just not possible. And you know what? That's okay. Because software testing isn't about chasing some impossible idea of perfection. It's all about managing imperfection. So, here's our game plan. First, we'll tackle that myth of perfection. Then we'll look at the blueprints for how software gets built. After that, we're going on a bug hunt. We'll also see what happens beyond just finding bugs. And finally, we'll try to answer the big one. What does quality even mean? All right, let's dive into that first big idea. If you can't make something perfect, why even bother testing it? Seems a little counterintuitive, right? Well, it all comes down to finding a balance between what's ideal and what's realistic. See, here's the deal. While the goal might be a perfect system, the reality is that trying to get there would cost an insane amount of time and money. It's just not practical. Testing lives in that gap. It's about being smart, finding the most serious problems so we can deliver a product that works well and does what you need it to do without spending forever chasing a ghost. Now, you might think testing is just this chaotic thing that happens at the end, but it's actually a super organized part of a much bigger process. To really get it, you have to look at the different blueprints or methodologies that teams use to build software in the first place. Think of a development methodology like a recipe for baking a cake. It tells you what ingredients you need, in what order to add them, and how everything should work together. Choosing the right recipe from the get-go is absolutely critical because it has a huge impact on how much the project costs and, of course, how good the final product is. So let's look at one of the originals, the waterfall model. It's super linear, very step-by-step. First, you figure out everything the software needs to do. Then you design the whole thing, then you build the whole thing, and only then, way down at the end of the line, do you test it. It's really rigid. If you find a major problem during testing, you might have to go all the way back to the start. It works, but only for projects where you know exactly what you need from day one and nothing is ever going to change. Now contrast that with a more modern way of thinking, Agile. Agile is totally different. Instead of one long, straight line, it's all about small, repeatable cycles. A team plans, builds, and tests just a little piece of the software. Then they get feedback, learn from it, and do it all over again, making the product better and better with each cycle. It's built for change. And the whole philosophy behind Agile is about shifting your priorities. It's not that having a plan is bad, but being able to respond to change is better. And sure, contracts are important, but actually collaborating with your customer is way more valuable. The main idea? Let's focus on what truly matters. Building something that actually works and that people want. And this really sums up the huge difference. Waterfall is like building a house from a strict blueprint. Once that foundation is poured, good luck trying to move the kitchen. But Agile? Agile is more like tending to a garden. You're constantly planting, watering, and pruning, adapting to the weather and the soil to get the best possible result. You can see why Agile is so popular today, right? It lets you adapt to what users actually want. Okay, let's get to the part everyone thinks of when they hear testing. It's time to go on the great bug hunt. Yep, this is the classic image of a software tester. Their job is to be an investigator, a detective, and kind of a professional saboteur. They poke and prod and push the software in ways no one else would think of, trying to find its breaking points. They have to think, how can I break this, so that the developers can then figure out how to fix it. But, and this is so important, we're back to our main theme. You can't build a perfect system, and you definitely can't find every single bug. It's just not possible. So the goal of the bug hunt isn't to achieve the impossible. It's to find the most critical bugs, the ones that really matter, so the team has the information they need to decide if the software is good enough to go out into the world. Now, you've probably heard a few different terms thrown around, like quality assurance and quality control. People often use them in testing to mean the same thing, but they're actually quite different. Understanding this difference is really key. First up, quality assurance, or QA. Think of QA as being about the process. It's the big picture. QA isn't about finding bugs in the final product. It's about setting up the system, the rules, the standards, the workflow to prevent those bugs from ever happening in the first place. It's all about being proactive and building quality in from the very start. Then you have quality control, or QC. If QA is about the process, QC is all about the product. This is the inspection phase. QC happens at the end of the line, where you take the finished piece of software and check it against a list of requirements. Does it do what we said it would do? It's a reactive check to catch any defects before they get out the door.
So where does plain old testing fit into all this? Well, testing is the action. It's the tool that makes both QA and QC possible. It's the hands-on, in-the-trenches work of actually running the software, trying to break it, and verifying it works. The results from testing are what QC uses to inspect the product, and that same data helps the QA team figure out how to improve the whole process.
This all brings us to one final, and maybe the most fascinating question. We've been throwing this word quality around this whole time, but what do we actually mean by quality? Believe it or not, there's no single easy answer. One of the classic definitions comes from a guy named Philip Crosby. For him, it was simple. Quality just means the product does exactly what you wrote down in the requirements. If it checks every box on the list, congratulations, you have a quality product. It's a very straightforward, black and white way of looking at it.
But other experts have pushed back on that. Joseph Duran asked, is the product fit for use? I mean, it might check all the boxes, but can a real person actually use it to get their job done easily? Then you have others who say it's all about satisfying user needs. And maybe my favorite comes from Gerald Weinberg, who said quality is simply value to some person. I love that because it makes quality personal. A product has quality if it's genuinely valuable to the person using it. So when you boil it all down, what's the real purpose of all this work? QA, QC, testing. It's all about gathering information. It's about providing clear, objective data that helps the team answer crucial questions. Is this thing ready to go? Did we build what we set out to build? And most importantly, it gives the business the real-world information it needs to make smart decisions. So there you have it, a peek behind the curtain at the world of software testing. And I'll leave you with this to think about. The next time you launch an app and it just works flawlessly, take a second. What's the invisible work you can see now? What bug hunts and debates about the very meaning of quality had to happen for you to have that smooth, easy experience? Pretty cool to think about. Thanks for tuning in.